right, we're rolling. If you got your notes, please, gentlemen in the back, suspend your conversations, and what can I say except welcome. For those of you watching at home, it was an inside gag. They were talking about the song from Moana, blah, 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 blah. I was making a blank, never mind. I am, however, much happier that I have fresh blue dry erase markers. Just the thing to review for backward problems.
Bring me a croissant. I love whatever you do. You roll your eyes back.
First, grab a calculator. Put it in radian mode. I want you to punch that into your calculator and tell me what you get.
Did you check out?
I'm sorry? I don't believe I did. I think it was pretty much just notes that with my calculator. So I think I can just grab it. Let's see, which one was it?
He didn't check out TV buddies.
Oh, anyway, oh, correct. Yeah. The really early ones I might have, but let me check those at the NPR.
Yeah, no, I have 4 that you have to check out.
Oh yeah, that is Monday, isn't it? What'd you get? Everybody in radian mode? It shouldn't really matter, but go ahead.
0.371.
0.3 roughly. Cosine of inverse tangent, 5/2. We got 0.37139, blah, blah, blah. What would I do on a test if it gave me that? I'd take off major points. Why? Why? So give me the exact answer. How? Refresh my memory from last Friday. What kind of a problem is this? I'm not taking a derivative. Not yet. This is a pre-calc problem. Beginning of the hour on Friday. Forward backward problem. Trigonometry forward backward problem. Jack, tell me how to set this up.
Well, you start by drawing a right triangle.
Correct. Now what?
You do the, what is it? You put 5/2 on there. You do tangent
Where?
first.
Where do
So
I
you
put the
pick where
5? Where do I
theta
put the
is,
2?
You pick where theta is. It can
Yes.
either be-
Everybody look up here. There are a few people who are not focusing. Please correct that. Forward backward problem means draw a trig shape. Again, 99% of the time, it's a right triangle. Then you have to mark what?
Where theta is.
Where theta is. You can pick, it's completely up to you, but pick theta somewhere. Otherwise you will not know where to put the next numbers. Polly, take over.
So opposite over adjacent.
Yeah, opposite over adjacent. Do it.
So we're gonna put 5.
Where do I put 5?
Across.
Across from it, okay.
And then 2 right underneath theta.
Correct. What should we do after that, Pete?
What would you call me?
Yes, I did.
So then you probably could find the hypotenuse.
Correct, do so.
It would be
How?
well, a squared plus b squared.
Okay, set it up.
So you get 2 squared plus 5 squared equals c squared.
Correct.
You get 4 plus 25 equals c squared.
Okay.
Which is 29 equals c squared.
Yep.
Radical, so you get radical 29 equals c.
Correct. And not square root of 29, because you don't do negatives. So, okay. How do you finish the problem? Julie Miller.
Um,
So we used Pythagorean theorem, got this missing side. Do the cosines. Go for it.
Opposite or adjacent over
Yes.
So
What would it be?
2 over
And in our class, you can leave it. In pre-calc, I would like you to take the radical out of there. 2 radical 29 over 29. Just, yeah, know that as a courtesy. If you run into people who aren't in calculus, it's nice to be able to do that, because you'll freak them out otherwise. Make sense? On your calculator, type in 2 divided by radical 29. See what you get.
Same thing.
Did you get 0.37139, blah, blah, blah? That's a good sign. That means that this is the exact answer. And this is what I would want on the test. Clear?
We're supposed to be in radian or degree.
Radians, unless otherwise specified.
Maybe we can keep our calculator radians for the next person.
Correct. Interestingly enough, forward-backward problems don't much care if you're in degrees or radians, but it's safe to keep it in radians in calculus. The only time you don't put it in, the only time you put it in degrees is when the problem specifies it. Pretty much calculus and radians are wedded happily ever after. Questions so far? Think you could do that if I gave you a problem like that? Which I probably will. Now, try this. Refresh my memory. F of x equals the inverse sine of x. Find the derivative. Just one more time. If you have it in your notes, great. But I want you to talk me through how to get it. I'll give you a hint. Start with y equals inverse sine of x. It's the exact same thing. Go.
You can do sine of y, then cancel the inverse sine, and just get x, y itself.
Right, look up here. Everybody focusing? I don't know how to take the derivative of this. We've never run into an inverse trig function before, other than playing it with a pre-calc as far as graphing and such. If you take the sine of both sides, these cancel. So you have the sine of y equals x. Now that does look messier, and we're not used to having y as an input variable, but you do know how to take the derivative now. Michael, take over. How do you take the derivative of sine of y? What is the derivative of sine of y? Cosine of y, what's at the end?
dy or something?
Yes, very good. Is equal to what? What's the derivative of x?
Yes.
Yeah, 1 dx, or just dx. Ever read so far? F prime of x, another way to write that is dy over dx. If you can get that, you'll be done. How? Polly, take over. How do you get dy over dx?
Divide by cosine.
Right, get dy first. So cosine of y, divide on both sides. Okay. Cancel. So dy is equal to 1 over cosine of y dx. Now what? Pete, take over.
Now you would have to divide by dx.
Divide both sides by dx. And that's exactly what we need. These cancel. There's only one problem. That's your answer, by the way. 1 over cosine of y, but it's not simplified. Because the original problem had an x in it. I want an x back. How do you do that?
Could you inverse cosine or something?
You're on the right track. I I want to, in other words, I want to get rid of the y. I don't want to get y by itself. I want to replace the y with something with x's.
If you replace it with like dy or dx or something.
Dy and y are two different things. There is something up on the board. What's y equal to? I kind of scratched it off when I canceled, but do you see it?
Oh, the inverse sine of x.
Y is the inverse sine of x. Plug that in. Show me what I have so far. From beginning to end. Dy over dx is equal to what? This is just because you divided by dx. So 1 over what? Cosine of what?
Inverse sine of x.
Exactly. How do you simplify that? Pre-calc, remembering people. Polly, take over. What kind of a problem is that? It's forward-backward problem. How do you do that? Yeah, draw a triangle. What kind of triangle look like? A right triangle. What next? Put theta somewhere. I don't really much care. Don't put theta in the right angle. But okay. Now what? You notice the last time I did, I had two numbers. I don't have them here. You do need two numbers. Is there a way to make two numbers? Yeah. Put an x over 1. Now try it. Take over. Where do I put the x? Where do I put the y? Correct. Get the inside first.
Do the opposite.
So top right above for x.
X is, or do you not switch it?
You said it was the opposite, right?
Yeah.
Opposite from what?
So like, is it still continuous now?
Yes.
Okay. So X is opposite.
Okay. So which way do I go? The top, the right, or the bottom? Yes. And where do I put the 1? On the top. Correct. Noah, take over. What do you do next?
You just do, so you say on the top of k.
Okay.
It's like a squared plus x squared equals 1.
1 squared, which is 1. Yeah. And then I'm trying to get a by itself.
You get subtract x squared.
Okay. You're going to get a formula here. You're not going to get an answer. Gentlemen, you're focusing on this and not on random
And
conversation.
then take the radical of that we just got.
Correct. What radical and not square root?
Because there's no negative answer.
Right. By the way, is radical 1 minus x squared equal to 1 minus x? No. I don't want anybody in here to do that. The minus sign destroys that. If it were 1 times x squared, it would work like a charm. But addition or subtraction, you're stuck with this. This is your missing side. Sorry. So, how do you finish the forward-backward problem, Michael? Here's the diagram for it. Here's what we were working on. There's one more step we haven't done yet. We did the inside part. We got the sign, inverse sign by drawing the picture.
So cosine is adjacent hypotenuse.
Go for it.
Radical minus x squared over root 1.
Yes. Simplify that for me.
1 over radical 1 minus x squared.
Right. Dividing by a fraction is the same as multiplying by the reciprocal. You are looking at the derivative of inverse sine. That's where we derived last Friday. This was just going through it a little faster because we're a little more comfortable with forward-backward problems now. Yeah.
I know we've asked this like multiple times for other things, like why we need to know this stuff, but this one I'm like seriously. I don't know when I'm ever gonna use that.
First of all, it's kind of an abstract philosophy question. If you're asking when are you ever going to have to use math above regular arithmetic, is that what you're asking?
Or just this like specific
This
thing.
specific thing, it's kind of like, Have you ever used factoring ever since first year algebra?
Oh, well, yeah.
Yeah. There were people asking in first year algebra when we were gonna have to use factoring. Answer, everywhere. If you go anywhere beyond algebra one.
Like the situation, like.
This particular one, if you ever take, like, you know how to take the derivative of like x cubed, right?
Yeah.
What is it?
3x
3x squared. Make sense? What's the derivative of sine? Cosine. What's the derivative of ln of x? 1 over x. What's the derivative of inverse sine? We wish. It's that. That's why we need it. In other words, we did not know how to take the derivative of any inverse sine, inverse cosine, inverse tangent until today. That's the answer.
But like real life situations.
That's getting a little more abstract than we really need. In other words, it's when it depends on what you want to do for a career. If you want to, I don't want to sound flippant here, but if somebody wants to be a manager at McDonald's, they probably will not need this stuff. If somebody wants to work in as an insurance actuary, you might need this stuff. Insurance actuaries use calculus on a daily basis. I have friends who are insurance actuaries, and they said that they had to go back to college and relearn all the calculus that they forgot from high school. Yeah. They show up.
What is this, and this is not me trying to be like, why are we doing this? Like, what is this finding? Like in the past year, you're like, by doing this, this is how we find, keep this part of the circle. So like, it's kind of understood, like, okay, when I'm trying to find
This, for example, we did a really brief graph of this thing.
What is this finding? I know it's finding.
I can give you a visual. That's about all. Then we'll have to go on to the next part. But does anybody remember what y equals sine of x looks like as a graph? Where does it start? Where does it go? There's max, base, min. Where does it start? Sine of x. Positive sine of x. It starts the base and goes up. Correct. What do you count by? Pi over 2. Excellent. How far up do you go? 1. How far down? Yeah. Nice. So max, base, min, base, and then you can go backward. Min, base, max. It looks like this. Does anybody remember from pre-calc what happens when you take an inverse of a function? There's one easy step by which you do that. Inverse means go backwards, go in reverse. Normally with any function on Earth, you plug in an x and you get out a y. Tell me how to do it backwards. Yeah.
Just flip it, like on the graph.
Yeah, plug in a,
X.
that's what you normally do.
Plug in a y.
Plug in a y and get out an x. X becomes the output, y becomes the input. You switch all the x's and y's. Remember that? When I give you a big, huge formula with x's and y's, if you trade every x with every y, the graph transforms into the inverse. Watch what I'm about to do. The inverse looks like this. X equals sine of y. And let me show you what that looks like. It's now sideways. Max. This is, by the way, pi over 2 is approximately 1.6 something? 1632? No, 1.57.
Never Father John talks about the square root of 0. I just want you to say it. You probably know it.
It's 1.4142135 blah blah blah. But
Yeah,
I don't want to
exactly.
get it by now.
That would be so funny, because all the kids are like, but every time I'm like, Mr. Cochran's saying they're saying it, he's
Yeah.
That's really, that's what I'm thinking. Like, he's the only one that knows.
See what I just graphed? Instead of going left, right, it's going up, down. That's this. Now look here. 30 more seconds. Look up here. Everybody. How do you get y by itself? Think for a second. You're not really multiplying. You're taking a function of both sides. What cancels sine? inverse sine. You have to do it to both sides. Do it. What happens over here? So y equals, congratulations, you're looking at the graph of this. And this is the tangent slope of it.
That's what I didn't understand.
Does that make sense? Derivatives give you the tangent slope. They also give you the rate of change if it's a physics function, the acceleration if it's a physics function, well, the velocity if it's a physics function. Take the derivative again, and you get the idea. In other words, there is stuff we're going to use this for, depending on what you do for a living. Why do I give you this stuff when 90% of people probably won't use this 10 years from now? Because I want to open doors for you. First of all, if you go to college and you say, I'm curious, like, I worked in the food service for 4 years in college. I flipped more burgers, I fried more chicken nuggets, I put together more salads, more wraps, I mopped more floors, ran more cash registers than I ever care to remember. But did I want to do that for the rest of my life? There were fun parts of it. You know, we actually got free chicken nuggets when we worked at cashier, but and when you worked in the dish room, which was insane, by the way, you got free sodas and like free, they pretty much fed you. And normally when you were working, you couldn't have a soda when you were off sweeping the floor because you have to present a good image. Dish room, they didn't care. You could just, okay, wash a couple more plates. In other words, there are perks. If somebody wants to work in food service for the rest of their life, that's great. If it fulfills them, great. I don't want to be the case where they're working in food service because they have no other choice. If they don't know any math whatsoever, the options get really, really limited. If people can't even do basic arithmetic well, you'd be surprised how many jobs that takes off the board. If somebody wants to do one of the really high moving, like earth moving, like society moving jobs, you're usually, like all the people who, there are loads of people who know how to play video games. Not that I'm talking about video games, this is an endorsement, but not many people know how to program them. And even fewer people know how to write the computer languages by which you program them. If you plunge into this stuff, which shows up all the time in computer science and physics, you open up door after door after door. You don't have to open them. You know, it's like, oh, that's interesting, particle physics. Nope, not for me, thanks. So I want to be a professional basketball player. Okay, but if it's an option, great. If you God forbid, you run over by a truck and your right arm gets, mangled or something like that, you can still fall back on particle physics. Whereas, Michael Jordan was absolutely amazing, but if he had broken both of his legs halfway through his career would be over. It's nice to have options. All right, I want to show you two more things. First of all, my suggestion to you, over here.
Wait, Mr. Croft.
Just a second. The derivative of inverse sine of x, please write this down, is 1 over radical 1 minus x squared dx. Everybody write that down. Even if you have it already, write it down. I'm going to put it in a chart. Let me get this thing out here. I don't really need this anymore. This is a buy one, get one free special. Looky up here. What's the derivative of the inverse cosine of x? Now, the normal way I would show you this is to slog you through another problem like that, which takes 5 to 10 minutes. I'm going to give it to you for free. And there's good news. Good news and bad news. Bad news is you have to memorize this. 1 over radical 1 minus x squared dx. The good news is there's a derivative of cosine inverse. Notice something? They're almost identical. What's the only difference? Negative. And by the way, that always happens when you take a derivative of a cofunction. That's the only difference. Now, bad news, but I will turbo it for you. Do it again, this one. Inverse sign. I want to do the exact same thing, and now that you've gotten a little more accomplished at it, we'll go faster. I want to take y equals the inverse tangent of x. Find y prime. Talk me through it. What do you do first? Remember what we did to the previous one. I have no idea how to take the derivative of inverse tangent, but I do know how to take the derivative of something else. I'll take over. I can't take the derivative of inverse tangent, but I do know how to take the derivative of what? Something we have seen before. Regular tangent. How do you get it? Anyway. Yeah, do the tangent to both sides. What would you get? What's the left-hand side? Good. Yeah. Now, take the derivative. Pete, take over.
So you would have to find the y to plug in.
Not yet. We sort of already did. What are we about to do? Do it.
So the derivative of tangent is
Exactly. When are we ever going to have to use this? In about 30 seconds. That's the answer to that question.
sine squared.
Close. Something squared.
Secant squared.
Secant squared. Nice. Secant squared of what?
Oh, secant squared of y.
Y. And then at the end?
Equals.
Something before that.
Oh, dy.
dy equals, what's the derivative of x?
Just one.
1, 1.
Dx.
dx. Michael, take over. What's another name for y prime?
Dy.
dy over dx. If you can find that, it'll be the exact same answer.
So you divide.
What do you get by itself first? I just want dy over dx.
Wait, I'm blanking on.
Just pretend it's an algebra problem.
No. What is the secant squared y?
Yeah, so what do?
Divide that. then-
Divide that, correct. So divide both sides by secant squared of y. Okay. Now what? Cancel.
Divide by dx.
Divide by dx. Good. Dx is canceled. So we have dy over dx is equal to what? Help me out.
1 over secant squared tan y. Or no, inverse tan of x.
Clever. And so it's secant squared of, and go ahead and plug this back in. Inverse tangent of x. And by the way, look up here. Secant squared is really the secant whole thing squared. Does that make sense? Whenever you do a trig function squared, it's the entire thing squared, not just the inside. Jack, take over. Simplify the bottom. How?
You have to draw a right triangle.
Yeah, it's forward, backward, probably. Do it.
Okay, put theta in
Yeah, wherever you like.
and you have
I need two numbers. I only see one.
x over 1.
X over 1. Nice.
So you have opposite is x, multiplication is 1.
Good. How do you find the missing side? Polly, take over. We use this to find the right triangle, and then what do you do with the right triangle?
Do 1 squared plus x squared.
Yeah.
C squared.
Go for it. Find C. What is 1 squared, by the way?
Just 1.
1. Okay.
No,
I'm sorry?
C equals
Uh-huh.
y minus,
Radical.
1
plus 1 plus x squared. Question?
Sorry, one second. Why does this squared go on the outside for this, the secant squared? Why does
Oh,
it go-
because
of the.
when you have secant of, let's just say u squared, that u can be anything you want. That's just a short way of saying secant of u whole thing squared. That's just by definition
Okay.
from last year. No, no. No, what do we do? That's C. Ollie, take over. We're not quite done with the forward backward problem.
How do you secant?
Secant, everybody look up here. By the way, I don't think you're chit-chatting about this. Okay, great. Not chit-chatting about the actual point I'm making, because I don't think I think you're about to miss this. How do you take the secant if you have the triangle? Okay. What is secant? What about sine? First of all, secant comes from what? These are the other things. The stuff we did last year is showing up now. That's the when you're going to have to use this. Welcome to when we're using it. So what is secant? What about cosine? It's a different word. Michael, what is secant? Secant is not the same as cosine. It's something when you do it to.
Opposite or whatever.
Not opposite?
Or it's.
There are 3 possible words and 2 of them are wrong. It's not opposite because that means just making it negative.
No, it's like it's other it has.
Because the opposite of 5 is negative 5. I'm looking for a specific word. All the other ones are wrong. We'll give you the wrong answer.
Sine, cosine, tangent, and then sine is.
I agree that secant goes with cosine, but what do you do to cosine to get it?
Oh, reciprocal.
Reciprocal.
Wait,
That's what she said.
You said
That was
inverse.
wrong.
Okay, if you said reciprocal, bravo.
That was so funny.
Okay.
You said reciprocal.
So Polly, take over. Finish the problem then.
That was so funny.
We're hanging on theta. I want cosine reciprocal. So what's cosine normally for SOHCAHTOA?
Adjacent.
So what is this gonna be? Yeah, and an easier way to do that, if cosine is adjacent over hypotenuse, what's secant? Gentlemen, I'm about to move people. This is getting out of control. Hear me? Go ahead.
Just behind.
Yeah, hypotenuse over adjacent. Do it. 1 over what? Squared. Radical 1 plus x squared over 1. Pete, take over. What's radical 1 minus x squared all divided by 1?
It's just radical 1 plus x squared.
I agree. Take that and square it. What happens?
Would it be 1 plus x squared?
Yes. What happens?
Just the radical cancels.
The radical cancels. You are looking at the derivative of inverse tangent. The derivative of inverse tangent doesn't even have a radical in it. It's actually the nicest of all of them. 1 over 1 plus x squared dx. We get these by doing forward-backward problems on the original problem. Again, can you do this during a test? Yeah. You see how long it takes? It usually takes an average of 5 to 10 minutes if you're going fast and if you don't forget any steps. It takes an average of 5 to 10 minutes to derive one of these formulas. If you're going to derive 3 of them, that's going to take 15 to 30 minutes. And if you have 55 minutes to do the test, that doesn't bode well. So I would recommend you memorize these. Good news and bad news. Bad news is you have to memorize this new one. Good news is, can anybody tell me what the derivative of cotangent is? Exactly. negative 1 over 1 plus x squared dx. You do not have to memorize the cofunctions. They're just negative versions of the originals. I do have to derive one more, and I'll try and turbo this. This one I'm not going to drag you through every single step, I'll just do it. But please do attend and don't start chit-chatting. I'm serious. I'm sorry, did we have that? After I erased it? Okay. If you need me to recreate, well, it's going to be on video too. Try this. Y equals inverse secant of x. Michael, what's the derivative of secant?
Over. Derivative of secant is.
These you need to know cold. If you don't, go back and drill them this week. You need to know the derivative of all 6 trig functions, like the back of your hand by the end of this week.
Well, it can't be negative 1 over.
It's not negative, because it's not a cofunction.
So it's just positive. It's just the sign.
It's a double one, if that helps. It's something times something. So the derivative of, just derivative of regular secant. We're not doing this one yet. The derivative of regular secant, like from the beginning of the year. What's that?
Secant tangent.
Secant tangent, correct. The derivative of secant, we're going to need this in a second, is secant tangent. Keep that in the back of your mind. Now, watch this. I don't know how to take the derivative of inverse secant. I'm just going to take the secant of both sides. So it's secant of y equals x. Now take the derivative of both sides, which, by the way, is why we need this formula. So it's going to be secant of y, tangent of y, dy equals 1 dx. If you're still with me. Once you know the formula for derivative of secant, you can do this step. Now, I want to get y prime. We do know that y prime is the same as dy over dx. So find that. We're going to divide both sides by secant tangent. Whoops. Whoops, don't have to do that yet. Everybody still following me? Right. We got this on video, so just check the video tonight. Cancel, cancel, divide by dx. Don't spend time chit-chatting, please catch up with socially later. You're gonna miss stuff. Dx is canceled. You're left with dy over dx equals 1 over secant of y, tangent of y. Can somebody tell me how to simplify this though? What do I have to do next? Because that is our answer, but it's not simplified. What do you have to do to finish the simplification? The original problem had nothing but x's in it. It says a bunch of y's.
But y equals,
What is y equal? According to
inverse secant of x.
inverse secant of x. It looks like this. dy over dx is equal to 1 over, bless you, the bottom is going to be big, so leave a lot of space. Secant of inverse secant of x times tangent of inverse secant of x. Clear? I just plugged in the y's. That's all I did. I replaced the y, replaced the y. That's now 2 forward-backward problems. Yeah. I do have a bit of good news. Look up here. One of those is much easier than you think. Anybody catch it?
Oh, we know what the second one is.
These cancel. And make what? X. That was nice. This one, not so much. We've got to make a, let me get rid of this. Isn't I? I think that was a sneeze. Let's draw a right triangle. I'm going to go fast on this. Here's theta. Tangent of inverse secant. Please. Read. Need you here too. X over 1. Secant of x over 1. Where do you put the x and where do you put the 1 to make secant make sense? Secant is the upside down version of cosine. Cosine would have been x adjacent 1 hypotenuse. I'm going to do that backwards. So what I just did. If you know it's the reciprocal, you just put them backwards. That's all you need. This thing I'm going to cut to the chase. After the Pythagorean theorem, it's radical x squared minus 1. Do the Pythagorean theorem if you doubt me. Now I want to find the tangent. Opposite over adjacent. So radical x squared minus 1 over 1. And the over 1 is kind of useless. We're left with 1 over x radical x squared minus 1. That is your derivative of inverse secant. So it's 1 over x radical x squared minus 1. And the derivative of cosecant inverse is nothing but the negative version of that. X radical x squared minus 1. Those are the 6 inverse trig derivatives. Again, my advice to you, memorize sine, memorize tangents, memorize secant, and the other 3 will come automatically. The derivative of any cofunction is negative, so it's just going to be the negative version of these. Clear so far? Now, how do you tell them apart? Derivative of inverse tangent is the only one that doesn't have a radical at all. All of them have x squared in there somewhere. It just depends on where. The first one, the 1 comes before the x squared. In secant, the x squared comes before the 1. You notice they're flipped under the radical for sine versus secant. They're traded places. And there's an extra x in front for secant. That's the only one that has that. Okay. So what I want to do is this. Here's an actual problem for you. Did I remove that? No, I didn't. Oh, are you serious? Hang on. Wow. You got Wi-Fi back temporarily and then it off. Wow. Give me a second.
Zero.
Pressure is being pursued.
That was right.
Got it. Correct. This is not going to be due tomorrow. It's going to be due Wednesday. Give me a second. I'll get it off the photocopier.
So you're not taking test?
I told you that last
Oh,
night.
I know.
It's like-
Michael, I literally told you last night,
Well,
you're like,
we
oh, you're
skipped
taking your
that
test
part.
tomorrow. I was like,
Yeah.
well, I'm not.
Okay, well, I was tired, but then also.
Oh,
at
okay.
Everest, you're studying for your test all the time. So
Yeah,
at least
I
you
am,
have it
because
as
I
a
don't
next
wanna
day,
forget.
so- Yeah, I know. So what's the
This isn't like,
official date?
this isn't like a time.
Thank God.
You don't realize, if I fail this test, I'm supposed to.
I know, that's my favorite part of it. That's my favorite part of it.
I have it scheduled, I have it scheduled for the other day, canceled.
How was your
Right.
day?
Where even is it?
For you,
Did Saturday?
this will be due on Wednesday, but grab a pen. I want to do one problem with you.
I didn't fly.
I'm literally in front of you. Grab a pen. I want to do problem number 1 together. We have a writing utensil? Worksheet in front of you? Let's do this. Number 1 together. Y equals inverse sine. Gentlemen, there's way too much talking. And yes, I'm waiting for you. Thank you. Of x to the 4th. You notice x to the 4th is not x. It's something bigger and weirder. What rule are we going to need in addition to everything else we just done? Chain rule. So when we're all done, we're going to have the derivative of x to the 4th multiplied at the end. But for right now,
We have to memorize, so can we just like,
For right now, just pull it off the board. Now, in the textbook, if you ever look in the textbook, they usually use the letter U instead of X. And for good reason, because you can plug anything in there you want. And the du at the end would be the chain rule. So you tell me. Just pretend this is the inverse sine of blah. Give me the derivative. There's not much work you have to do once you memorize these. 1 over definitely. Radical 1 minus blah squared times what?
4x.
The derivative of blah. Do that. By the way, what is this? Can somebody simplify me? So it's 1 over radical 1 minus. Anybody? Don't work too hard.
X squared.
X to the 4th
Oh, yeah,
squared.
yeah,
X to the 8th. And then what's this? What's the derivative of x to the 4th? No problem. Don't work hard there. It's an old-fashioned problem. What's the derivative of x to the 4th? 4x to the 4x to the 3rd. Here's your final answer. That's really over 1. It's on top. Got it. It's the end of the problem. Does that make sense? The only thing weird is they deliberately put weird things in the input slot. So you're going to get some rather strange stuff out for chain rule. That's the only difference besides these. And don't forget, when you're doing the derivative of inverse cosine, cotangent, cosecant, it'll be the negative version. Okay? So go ahead and get started. You should have all the, I mean, not now, but we're out of time. But, and I should give you some time tomorrow to work on this in class. But, any questions? Making sense? Again, you have some memorizing to do. These. There are 2 main topics we need to cover before the end of the year. This is one. Inverse trig function derivatives. I will also have you do some of these backwards. If I give you a problem like this and to say take the integral of it, and you'll get an inverse trig function as your answer. The second topic I'm mainly going to cover at the end of this week, beginning of next week. It's called partial fractions. Last questions. Alrighty, please stand. We are out of time.
You said this was due Wednesday.
It is due Wednesday, it is not due tomorrow. And you will have some time to work in class, so after we get done with the brush up things, yeah, tomorrow. Let us pray. In the name of the Father, and the Son, and the Holy Spirit. Amen. Glory be to the Father, to the Son, and to the Holy Spirit, as it was in the beginning. Alright, see you all later. Those of you watching at home, enjoy, talk to you later, bye-bye.